Direct heat cooking is about learning how radiant and convective heat work together. This is the BBQ Nerds Podcast. We don't argue brands or chase opinions here. We talk through how smokers behave so things make sense. Welcome back, BBQ Nerds. I'm Frank Cox. I'm the BBQ Pit Engineer. And on today's episode, you guessed it, we're talking about direct heat and specifically fire structures that we typically use in those smokers. So the one thing we want to do, though, is we want to explain how this style of pit behaves, not just which style of cooking is better. So I won't be the guy to tell you that one style of cooking is far better or far superior than the other, because they all have their certain place that they operate. So for the sake of this episode, we're going to be focusing on what I call enclosed, radiant dominant direct heat cookers. Now, these are not Santa Maria grills. These are not open style, just charcoal grills. These are grills that are specifically designed with the intent to cook over embers, a coal bed, wood, but be able to close a lid like our smoke slinger pits, for instance. That's why we call them enclosed. So this episode also builds on previous episodes such as fire behavior, which is episode 2 of this season, and draw, which is episode 3, and then our last episode, which was fire structure for offsets, episode 5. So if you haven't listened to those episodes, please go back. I think you'll get some value out of them. So one more time, we're explaining how the pit behaves, not which style is better. Now, something that we need to really talk about here is the misunderstanding that accompanies direct heat. So you'll see a lot of different brands, different companies out there that will use the terms direct heat whenever they're talking about a specific kind of cooker. Now, some things that we could probably clarify real quick. Direct heat gets lumped in with those other styles of cookers that I mentioned, like open, just regular old grills, Santa Maria type cookers, which if you don't know what a Santa Maria type cooker is, you can Google it and look it up. But essentially usually there's no lid and the grate raises up and down over a bed of coals, except usually they're using them with open fire, like actual flames. And that's how this differentiates from those. Argentine style radiant cooking, when I say that, we're talking more like it's similar to a Santa Maria grill, that it does go up and down, but they usually use a bracero, which is like for burning wood down to embers. And then they're shoveling embers under whatever they're cooking. And they're controlling, it's more open flame or open fire, but it's over embers, not flame. So this kind of cooker here is specifically an enclosed direct heat pit or direct heat smoker. And people have a tendency to mix up very different systems. For instance, in this case, most advice people hear is usually like from offset smokers, like offset centric. And I think it's just because we are so used to working with air, cooking barbecue, with the assumption that any kind of direct radiant heat is usually a problem. And that's not exactly true. So applying offset logic to a direct heat smoker is actually like apples and oranges a little bit. So that's where a lot of the frustration comes from. In these kind of pits, like smoke slinger style direct heat smokers, radiant heat is dominant, but convection still matters. And we're going to get into that here as we keep going with this episode. The big thing to remember is that in a direct heat style cooker, these enclosed direct heat style cookers, airflow does not do the main cooking. What's going to happen is that we're going to be looking at radiant leading how the smoker runs, and the convective part of our airflow and all of that is what supports the way that a direct heat cooker operates. So what happens is in the direct heat cookers, we're usually cooking with a coal bed on the bottom. It could be directly on the bottom. It could be in a charcoal basket. Some people love to use the word fire management basket, which is like something that you would use in an offset smoker a lot. And what the key to remember is that we're enclosing the fire the fire basket, the charcoal basket, the coal bed, we're enclosing that into the same space where we have our food that we're cooking on the cooking grate. That's why we call it a direct heat pit. So radiant heat is the primary heat source in this cooker. That's where the heat is coming directly off the coal bed. And as we discussed in previous episodes, radiant heat is omnidirectional. It goes every direction. So it doesn't, the only thing that prevents it from going a certain direction is some kind of a shield, we're going to call it, or a baffle, or an insulated panel of some kind. Other than that, radiant heat is line of sight, and it's going to go every direction. So the way that we control these kind of cookers, a big part of it is distance from the coal bed. So that matters more than our air temperature. And also coal bed size and the geometry of where this coal bed is placed, that also has a huge amount to do with how these cookers cook. So radiant heat energy does most of the cooking. So the key trade-off here is that since we have strong radiant heat sources here in these cookers, you're going to have to react a little bit quicker whenever you're cooking. The other thing is that mistakes can show up a little bit quicker. For instance, too big of a coal bed. So convective heat in these smokers, direct heat pits, that's how we move heat and smoke together around the pit. And what this does is it helps us to even out temperature differences across the pit. In the smoke slinger pits, we have tuning plates in there, and we use those along with the exhausts and where they're placed in order to force that convective airflow to go a certain one direction or another. So another thing is that it's going to help us with our barbecue KPIs, as we've talked about in the past episode, like for surface drying and bark formation and things like that. So an important distinction here, and possibly an easy way to remember and visualize how a direct heat smoker actually works, is convection shapes the cook, but radiant heat drives the cook. So here's how that combination might feel different than offsets. Offsets are convection dominant, and radiant is a secondary thing. We actually try to lean into airflow and how it runs through the pit and how air affects like bark formation and all of that stuff, as you heard in our episode about barbecue KPIs. However, radiant heat is almost like we want to get rid of it. We don't want it to be like a dominant force inside of our airstream. We inject baffle plates into the pit. We have even offset the firebox in order to, in an effort to control how that radiant heat is dealt with when it comes out of that fire. So, like I said, with direct heat pits, we're radiant dominant, and the convection actually fine tunes our cook. That's how our air moves through the pit underneath of tuning plates, or if it goes up and spins off the lid, it might come up under tuning plates and then go up through a gap and reverse and go a different direction and come out of the pit like on the smoke slinger pits. And it can really have an impact in how our barbecue turns out at the end of the day. So when radiant heat leads and convection supports the cook, the pit becomes predictable. And that's in this direct heat application. So fire structure is another thing that we got to discuss here, like how to run a direct heat pit without just sitting there fighting it, without it running wild on you and getting out of control on temperature, or if a coal bed is like getting exhausted and then all of a sudden your temperature starts to plummet, different things like that. The bottom of your food getting burnt because of the way that you built the pit. So what we're going to do is we're going to talk about coal bed structure first. And, like I say, we're dealing with radiant heat in this cooker. And as with any cooker, coal beds are the most important factor in how we achieve our cooking temperature that we're looking for. And overall, how that pit is going to respond to us based on different things that impact it. So the coal bed is the primary control mechanism in this style of smoker especially. And, shape of the coal bed matters more than size alone. For instance, a tight coal bed is a really intense radiant zone. So if you have, like when I brought up earlier these fire management baskets, a lot of times they're shaped like a V and they're tall but narrow. And so whenever you do that, you're going to have a lot more surface area around the outsides of whatever that charcoal basket is that are exposed to convection air going across them. And it's going to basically superheat that air mass as it's moving. But then also now you've got a lot more coal bed exposed to the oxygen that comes into that smoker or cooker. And so now it's going to have a much more intense radiant zone right above it. However, if you were to spread that coal bed out along the bottom, it's going to be a wider zone, but not all of that coal bed is piled in one spot. So you don't have that intense zone right in one place. Now, neither one of those scenarios are wrong. It's just how you're controlling the pit. So we're controlling geometry in the pit for where our coal bed is, where our temperature zones are. For instance, cooking hogs. If you go to my brother, Carlton Dudley, shout out to Carlton, go over to his channel, Carlton's Cooking on YouTube, and you can see a video where Carlton did a whole hog on his smoke slinger, and I was there to help him film that. And he'd set up his coal bed in a very strategic way, directly on the bottom, and he piled it in the corners. And the corners were strategically placed like that because we want to get more heat on the thicker cuts on that hog. For instance, the hams and the shoulders. We don't want to have a big coal bed underneath the belly because that belly will cook way faster than the shoulders and hams. And so also that's going to give us the ability to control what cuts of meat get done at what timing as well. And then we can always move that coal bed around in the pit in order to get that whole thing done at the same time. So that's what we're talking about when we speak about geometry and not numbers. Like, we're not looking for a 2-hour burn here. We're looking for the right kind of burn. Fuel strategy is another element of this. So, if we're just cooking with charcoal, you're going to get a stable, longer burn, and you're going to be able to move that coal around under the pit. So you're going to get more of a radiant output. You're going to get a more predictable radiant output as well. Now, if we switch over to just wood on this fire, now we're going to have to deal with convective heat, because in order for wood to combust, it requires a lot more oxygen mixture for that wood to burn clean. Now, the main purpose of wood in any pit is not just, it's like a spice. I heard somebody the other day call it a seasoning, and actually that's in my notes here, is that wood is more like a seasoning. But what you're going to get from it is a short-term intensity right over the flame. Actually, Al Fragoni, in his cooking class I took a couple years ago, he said flame is bad. And he actually goes out of his way to put flames out whenever he's cooking. And as I've probably alluded to, Argentine style cooking is a lot like what we're trying to do inside of a enclosed direct heat cooker. We're trying to cook with radiant heat, which is what they're trying to do. We don't necessarily want big flames, because big flames just equals another thing we've got to control. And, we're working with like trying to build a crust almost like on the 90-minute ribs. The reason that whole thing works is because of the relationship between like an Argentine style cook and the kind of cooking we do in a direct heat cooker. Direct heat ribs, so to speak, So you're going to get from wood, you're going to get flavor, and that's definitely different than Argentine style cooking. Al specifically told me that you really don't get a wood smoke flavor from Argentine cooking. You get more of a texture and a style of open fire food. And it's incredible, but he's right. You don't get like a smoke penetration. You get more of a crust that you're forming and a really great texture. It's very basic barbecue. So wood is flavor, it's a seasoning and stuff like that. When you add wood into a pit like this, you need to add smaller pieces of wood, because we're trying to get that to turn into coals, which is our primary driver of our cook, and we still want to get that flavor. And then a blended fire, of course, is where charcoal's going to carry our cook and wood's going to accent what we're doing. Now, you can burn all wood in an enclosed direct heat cooker, but that's what we're talking about with that short-term intensity. Every time you add that split on, if it's a preheated split, it's going to combust faster, and you're going to wind up with that short-term intensity. If it's a cold split that come right off the rack, it's going to take a little while for that split to get on fire and start to heat up and get to where it's burning clean. And then you're going to have that short-term intensity after the fact. So you'll get a dirtier smoke up front, and then you'll get that short-term intensity we're talking about. So as far as airflow management goes, airflow in a direct heat cooker like this is going to control how clean our fire is primarily. So like the fire cleanliness, the combustion quality, it's not going to control like your cooking distance, which is how we can determine how fast our cook is going to go, in other words. So small intake changes with airflow equals big intensity changes. If you were to open up an inlet, you're going to let a lot more air into that fire. If you close it too far, you're going to choke it out. And if you choke out a fire, you're always going to wind up with dirtier smoke, is what's going to happen. So in direct heat cookers, my preference is if I'm going to use embers only, then I want to have it set up to where I've got minimal airflow so I don't get huge spikes. And also too much air to a coal bed will just cause it to burn out faster. You won't get as much length in your cook time on that coal bed. So as far as zones, that's how we're cooking. You'll hear me use the word cooking zones or temperature zones a lot when I'm cooking on a smoke slinger pit. I talk about it a lot on every pit, but primarily on a direct heat cooker. One of my favorite things in the world is a multi-zone cook, where I've got one super hot zone and then one zone over here that's chilled out. Not chilled out, but just more relaxed for cooking. And so what we're doing is we're primarily looking at temperature zones, not chamber temps. So what I mean by that is like the closer to the coal bed you get, the hotter the zone is. So if you wanted to have like a medium zone, which in my mind, a medium zone is between like 275 and 325. That's what I would consider a medium zone. You're going to want to be up away from that coal bed, probably a couple of feet, or 20 inches, something like that, which would be about where our cooking racks are in the full size and the mini smoke slinger. If you want a even cooler zone, that's where we're going to have that coal bed off to one end of the pit, and then we're going to have our food cooking on the other end of the pit. So you can actually almost pretend it's a thermostat by moving your food around in the pit instead of like chasing damper settings and all of that. So you can almost say distance is your thermostat. And this actually, when I first came upon this concept, I was at Al Fragone's class, and he always uses his hand. Actually, in the class, he'll joke around and say, let me go get the thermometer. And then he'll just like look at you like you're a dummy, because like we don't use thermometers in his kind of cooking. We use our hands. And what we're looking for is the intensity of the radiant heat. It's almost like infrared is what we're dealing with, that infrared spectrum. And that can't necessarily be 100% measured by a thermometer. It's almost like a ceramic burner on a grill. So you can tell that it's way more intense when that radiant heat is being reflected out of a ceramic plate or something like that. And so that's what we're dealing with here, is we're looking at that infrared or radiant heat intensity. And in open fire cooking like Al does, he'll take his hand and he'll count how many seconds he can hold his hand under whatever he's cooking. And the amount of seconds, there's like 3 ranges he uses, 2 to 6 seconds, 6 to 10 seconds, and then 10 to like 20 seconds or more. And those are low and slow, regular, medium, high cooking, and then hot and fast is what those are in reverse order. So an 8 to 10 second heat intensity is actually like a really, really good zone. So whenever you're moving from that high intensity to that hot zone, to a medium zone, to a cooler zone, you're actually adding time to your cook. And that's really key here, because with a direct heat enclosed cooker, we can actually close the lid. And so we don't have a bunch of cold air blowing on our food like you do in open fire cooking, for instance. Open fire cooking, you've got to also deal with the wind, and that can be a problem. For instance, we just cooked a whole steer at Al Fragoni's event back in Hondo back in the beginning of November. I was on Big Javi's team. If anybody knows Javier, he's a heck of a guy, and he makes these crosses that you can cook whole steers on. And that was a really educational experience for me, because I never cooked an animal that big in one shot. But also wind was a huge issue, because it's on the plains down there, the prairie, down right below hill country, and the wind blows there constantly. And so you got to deal with that. So distance is your thermostat. That's the key point to bring away from this. This is where like direct heat becomes intuitive, and you can use your barbecue KPIs, which is your senses, to tell what's going on, and you can trust those better than you can a thermometer number. So running heat at different levels, there's a few ways to do this. So if you want to run different heat levels, like a lower direct heat, one way you could do that is with a smaller coal bed. Another way you could do that is with more distance. And what that'll yield is longer exposure for whatever you're cooking. And that's key with a lot of different things. Most of the time, I'm cooking in the medium direct heat, which is that 8 to 10 seconds zone we were talking about. And on the thermometer, if you're going to look at it on a smoke slinger direct heat cooker, that's typically going to be reading somewhere around 325, but ignore the number. That's not what we're doing. We're cooking with radiant heat in this scenario, like for 90-minute ribs. And so what's going to happen is that's going to be the most forgiving environment. When you're cooking in that zone, you just make a time change to what you're doing. That's why we can get a brisket done, a full packer brisket. We can get it done in 7 hours on a pit like we make, and it doesn't take like 12 hours to cook, because we're using the radiant as our driver and convective is shaping our cook. Now, on the hot direct heat zones, if you wanted to run super hot, that's where you're going to be moving your coal bed closer to the meat that you're cooking. For instance, I'll put the charcoal basket up on top of the tuning plates when I'm searing. Or if you wanted to put your food lower in the pit on a lower rack, closer to your coal bed, it's going to change the timing of your cook to where you have shorter exposure. But anytime you shrink time on the length of a cook, you're going to have to pay way more attention, and you're going to have to not panic. Like, you're not going to set it and forget it and walk away. That's not how hot direct heat works. So the trade-off language here is direct heat. I love this statement. Direct heat trades time for attention. In other words, the less time it takes, the more attention you're going to have to give it. And that's a really good thing, like, to just keep on top of your mind. So anyway, something, just to here's some key takeaways. Direct heat isn't actually chaotic. One thing to remember is that radiant heat leads and convection supports your cook. Another thing is coal bed geometry creates control. You can control that cook simply by having your coals either spread out or built up. Distance matters more than the temperature on your thermometer. That's a huge, huge change to the way I've been cooking personally all these years. I started experimenting with that a couple of years ago after that class, and it's really changed the way my barbecue turns out. And once you understand the interaction that you need to have with your direct heat enclosed cooker, it stops being confusing. When you understand how a smoker behaves, it seems like everything makes more sense. So, hey, I appreciate you listening to this episode. It sure is a joy to make these. And, I'd invite you, if you don't mind, if you don't already, click the follow button on whatever podcast platform you're listening to so you don't miss an episode. And, make sure that you invite another barbecue nerd to listen along. Next time we're going to be together is next Tuesday. And the episode's going to be Episode 7, Fire Structure for Charcoal and Gravity Smokers, completing our fire structure series. And, I would encourage you while you're cooking this weekend or whenever you're cooking, watch how food reacts closer and farther away from the coal bed. Adjust distance instead of dampers when you're cooking in a pit like this, or even a regular barbecue grill. Experiment with coal bed shapes on your next cook and see how they affect your barbecue. Okay, guys, so that's it for this week's episode. Till next time, keep your smoke thin and blue, and we'll see you on the flip side.